We have two versions of the unknown for this given equation, both of which can be found in both sides of the equation. Our original equation here is given as 6 minus x is equal to twice x, or simply 2x. We are going to solve for the value of the unknown here. Now we are going to apply necessary properties of equality and other operations in order for us to isolate the said unknown on either side of the equation, but only one side of the equation. Now, there are a lot of steps that could be done here. I'm going to present you another step which will involve another property of equality. Of course, you may have your own method, but I'm just going to present this to highlight that said property. Instead of removing this 6 here, saying minus 6, and doing the said on the other side, we will still have a binomial on the right hand side here. And aside from that, if this will be removed, our variable here, or the unknown, is negative. Now for some of us, negative coefficients are a little bit difficult. Hence, as mentioned, I'm going to do this certain process. Instead of removing 6, I'll be removing x here. So since this is negative x or negative 1x, I'm going to add here x, so that negative x plus x becomes 0. This means that I am choosing the right hand side of the equation to contain the variable x, because if I'm going to add here x, because of the property of equality is telling us, we will have here this equation. 6 is equal to 2x plus x is 3x here. Now with that, we don't have negative signs, and it'll be easy or easier for some of us. Now with this, we can proceed by dividing 3 here, because 3 divided by 3 is just 1. Doing the same thing on the other side, you will have an equation here. 6 divided by 3 is 2, equal to x. Again, I'm choosing this method because I would like to highlight the symmetric property of equality. The symmetric property of equality is telling us that if we have this equation, we can simply interchange both sides without altering the values nor the signs of the terms. Hence, we can just simply rewrite this as x equal to positive 2. That's the symmetric property. Now if you're going to choose removing 6 here, you will still get the same result. I'm going to show you that here for this version, just for those who are wondering if we will get the same result if it's 6 that we are going to remove. So I'm going to subtract here 6, that will become 0. Do the same thing on the other side. You will have here negative x, as mentioned, is equal to 2x minus 6. Now, since we will be having x on the left hand side, we'll be removing 2x here. So 2x minus 2x is 0. We will do the same thing here. And as mentioned, this might be difficult for some of us who are struggling with negative signs, because negative x minus 2x is negative 3x equal to negative 6. Then you will divide here negative 3 to cancel that, and negative 3 here. Of course, you will still end up with the result of x here, which is now on the left hand side. No need to use a symmetric property. Equal to negative divided by negative is positive. 6/3 is 2. Take note, you will get the same result no matter what you do, as long as you choose or use the correct operations. But this might be difficult for some who are dealing with negative signs. Hence, you can stick with this and apply the symmetric property here. Now, either way, we will get the result of 2, and we could still check that using this method. We will have the original equation, and let's find out if the equation will hold if the value of x being 2 is substituted in the equation. If the equation holds, that means the result of x equals 2 as our unknown is correct. Now to do that, simply substitute the value of x here, 2, equal to 2 times 2. And take note, we are checking, so we just simply place here question mark. Now, 6 minus 2 is 4. The other side is also 4. You reach a point where both sides of the equation will have the same value. This means that your checking is done and you have verified that x being 2 or 2 is equal to x or just this as correct answers for our unknown. Join us to the next adventure involving the unknown.